Let's talk about temperature and density. All right, we have three temperature scales: degrees Fahrenheit, degrees Celsius, and in kelvins. Or absolute zero scale. So here the key is to compare these, look at the freezing and boiling point of water. In Fahrenheit, that's 32 and 212, and the difference between that is 180 degrees. In Celsius, water freezes at 0 and boils at 100, so there's 100 degrees Celsius in that space between freezing and boiling, which tells us that there are 180 degrees Fahrenheit for every 100 degrees Celsius. This is going to give us 1.8 degrees Fahrenheit per degree Celsius. Now, in the Kelvin scale, water freezes at 273 and boils at 373. And there are 100 kelvins for every 100 degrees Celsius. So if there are 100 kelvins for every 100 degrees Celsius, then these are 1 to 1. Now, the only other difference that we have here is an offset. So when water freezes, in Celsius it freezes at 0, and in Fahrenheit it freezes at 32. So the temperature in Fahrenheit is going to equal the temperature in Celsius plus 32, but we know there's 1.8 degrees Fahrenheit for every degree Celsius, and so we multiply this by 1.8, and that is going to give us the temperature in Fahrenheit. Now, to get between Celsius and Kelvin, we realize that 0 Celsius is 273 Kelvin, and so at this point we can finish our conversions. Because the degree size is 1 to 1, the temperature in kelvins is equal to the temperature in Celsius plus 273.15. And if I want to go from Celsius to Fahrenheit, I'm going to multiply by that 1.8 and add 32. So if I want to go from 2500 degrees Celsius to Kelvin, I'm simply going to add 273. I don't need the 1.5 because I don't have those number of sig figs. And my temperature in Kelvin is going to equal 2773. If I put that in the correct number of sig figs, it's going to be 2800 kelvins. Fahrenheit to Celsius. Well, to convert this and get back to Celsius, I'm going to take the temperature in Fahrenheit. I'm going to subtract 32 from it. I will divide by 1.8, and that's going to give us the temperature in Celsius. Make sure you put a parenthesis on that. You start the calculator in your head. So when I do this conversion here and I subtract 45 and I minus 32 and I divide by 1.8, I'm going to get 7 degrees Celsius. Now, if I want to go from kelvins all the way to Fahrenheit, it's going to be 2 steps. So I'm going to take 310 kelvins. I'm going to subtract 273. And since I've got to pass a decimal there, I'm going to need to include the 0.15. And that is going to give me a value of 36.85 degrees Celsius. I know that to get to Fahrenheit, I'm going to multiply by 1.8 and add 32. And when I do that, I'm going to get 98.6 degrees Fahrenheit. All right, density. First of all, density is a ratio of mass per volume and is an intensive property, independent of how much. Heavy, on the other hand, is just how much something weighs. So, for example, a bale of straw or hay here would be heavy, but it is not particularly dense. It's not particularly tightly packed. A magnet, this is a very small magnet, is not going to be heavy, but it's very, very tightly packed and it's going to be very dense. The density, by definition, is the mass over the volume. For a solid, we can do the volume in milliliters or we can do it in cubic centimeters. So the density is going to equal the mass over the volume in either mils or cubic centimeters. So if I have a liquid whose density is 1.5 grams per mil, and I want to know what is the mass of half a liter of that liquid, realizing that this is a conversion factor, and I know that in order to get into grams, I'm going to need mils. So I'm going to start out with 0.500 liters. I know my conversion from mils to liters, and I know there's 1,000 milliliters per liter. And then I know that there are 1.05 grams per milliliter. My liters cross off, my mils cross off, and I'm going to get 525 grams. This is exact, and the other two have 3 sig figs. All right, now things have very different densities. The density of lead is 11.3 grams per mil or cubic centimeter, and the density of water at room temperature is 1 gram per cubic centimeter or 1 gram per mil. So if I have 12 grams of water, what is the volume that's going to be occupied? Well, if I've got 12 grams, I know that water has a density of 1 mil for every 1 gram. Remember that a centimeter cubed is the same as a milliliter, and that's going to give me a volume of 12 milliliters. But if I want to know what it is for lead, lead is much more dense. If I take 12 grams and I realize I've got 1 milliliter for lead for every 11.3 grams, the same mass of lead is going to have a completely different volume, and it is going to have a volume of 1.6 milliliters. The denser it is, the more tightly packed it is going to be. So what is the mass of 125 mils of mercury? Well, I know that the density of mercury is 13.6 grams per cubic centimeter. And I remember that's the same as 13.6 grams per mil. So I'm simply going to take 125 milliliters. I know I need milliliters in the denominator, so I'm going to put 13.6 grams up top. And when I multiply through, I'm going to get 1,700 grams. All right, Dr. Jones. This is from the movie Raiders of the Lost Ark. And Indiana Jones here has clearly assumed that the densities of these two objects are the same. And he's assumed that because the volumes are the same. The volume of his sand that he's going to use to replace his statue with is the same as the volume of the statue. There's a couple of problems with that. One, that statue is solid. He knows that. He's got a PhD in archaeology. And two, we know that these densities aren't the same. We know that, in fact, gold is about 10 times more dense than the sand is, meaning he would need about 10 times as much volume of sand to replace the mass of that gold. And in fact, later on in this movie, he actually picks this gold statue up and throws it, and somebody else catches it. So let's just take this to its logical conclusion and figure out what the statue might weigh if it was solid gold. So we're going to assume a volume of the statue of 1 liter, because that's kind of what it looks like. Well, we know that that's 1,000 milliliters, and we know the density of gold is given as 19.3 grams per milliliter. So this statue weighs 19,300 grams. All right, so let's figure out what this weighs in pounds. Well, for a quick note, there are about 2.2 pounds in 1 kilogram. And we know that there are 1,000 grams in a kilogram. So let's use those two conversions and finish this off. So if I have 19,300 grams, and I've got 1 kilogram for every 1,000 grams, I'm going to get a mass of this of 19.3 kilograms. And if I realize there's about 2.2 pounds per kilogram, I'm going to get a mass of this statue of about 42 pounds. One of the things I love about Hollywood is they consistently underestimate the mass of gold and do things like that scene with the gold statue.